Okay, hi guys, so let's discuss some more questions on molarity and molality which we discussed in the previous lecture. Okay, so let's get started. So you have to convert 40% W by W solution of, let's say, NaOH solution into molality of the solution. Okay, so I've been given that 40 gram NaOH exists in 100 gram water, or rather 60 gram of, this is 100 gram of solution rather, and this implies 60 gram of water. Okay, so molarity or small m would be number of moles of NaOH over weight of solvent, which is 0.06 in kgs, so that would be 16.66. Next question is, we are interested in calculating mole fraction of solute in its 1 molar aqueous solution. So 1 molar aqueous solution is number of moles of solute divided by mass of solvent into 1000 if mass of solvent is in, we are taking it in grams. Okay, so this implies number of moles of solute would be mass of solvent in grams over just a second, yeah, over 1000. Okay, so mole fraction is calculated as moles of solute, which is n here, divided by moles of solution, which is n plus solvent's mole, which is, solvent is obviously water because it's a aqueous solution, and its weight would be, molar mass of water would be 18. Okay, so mole fraction would be something like this. N is obviously m of solvent upon 1000, again m upon 1000 plus m upon 18, all m's get cancelled out. Okay, so in the end we will be getting 18 upon 1018. Okay, so this would be the mole fraction. Let's take another example. So here we have to calculate, or rather mole fraction is given, mole fraction of urea with molar mass of urea as 16 gram per mole in aqueous solution is 0.02. okay, and density of solution is 0.99 gram per mole. Okay, so you have to calculate molarity and molality. So we have whatever all information we have to use that information and calculate molarity and molality. So molarity is number of moles of urea divided by volume of solution. Okay, so let's say it is in ml into 1000. Okay, so mole fraction of urea is given. Mole fraction is moles of urea divided by mole fraction is moles of urea. I'm writing n urea over n urea plus mass of solution or rather solvent over 18. This would be the moles of water, and summed up moles of urea plus moles of water would be the moles of solution. Okay, so now let's say we have x grams of urea in the mixture, or x grams of urea in the solution. So the moles of urea would be x over how much? X over, or rather before defining x, let's actually take a simpler approach. Okay, let's not get into the variables. We can directly assume that as we have been given that the mole fraction of urea is 0.02, then let's say we have one mole of solution. So if you have 1 mole of solution, then urea will have 0.02 mole. 0.02 mole of urea would be present in the solution, and moles of solvent would be 0.98. Okay, then we can calculate that the weight of solute would be 0.02 into 60, which is the molar mass of urea. Okay, and weight of solution, weight of rather solvent, not solution, solvent would be 0.98 into 18. Okay, hence weight of solution would be 0.02 into 60 plus 0.98 into 18 grams. Okay, so this would, if we calculate it, it would be 18.84 grams. Okay, so from this information we can calculate volume of solution, which is nothing but weight upon density. So density is 0.99 only, so we can directly write it, it will be nearly equal to 18.84 ml. So from now, molarity can be calculated as 0.02 is the moles of urea divided by 18.84 into 1000. It will be the molarity. Okay, and similarly molality would be 0.02, which is the number of moles of solute divided by weight of solvent in grams into 1000. What is the weight of solvent? Weight of solvent would be 17.64. Where did we calculate the weight of solvent? This is 17.64 grams. Okay, so from here molarity and molality can be calculated. Okay, next let's see another question where you have to convert 20% W by W solution of aqueous NaOH into, so 20% W by W aqueous solution of NaOH into molality, okay, as well as molarity, and you have been given that density is 1.2 gram per ml. Okay, so from the given question, 10 grams NaOH is contained in 100 grams solution. So in other words, 80 gram water is there, because this is aqueous. 80 grams solvent or water is there. So what would be the molarity? Molarity would be weight given of NaOH divided by the molar mass. This will give us the moles of NaOH divided by the volume of solution. Volume of solution is simply 0.1 liters. So from here you can calculate molarity. Okay. I'm sorry, this is this is this is the weight of water. We have not yet calculated the volume of solution. Okay, so for calculating molality can actually be calculated. Molality is obviously what we were doing where molality was molality only, not molarity. Okay, so from here we can actually calculate the molality. Now the part remaining is molarity. Part remaining is molarity. Okay, so molarity would be, you have been given that the density is 1.2 gram per ml. Okay, so simply you can have that volume of solution is simply weight of solution divided by density of solution. Weight is obviously 100, density would be 1.2. This is ml. Okay, so molarity rather would be 20/40 over volume of solution would be into 1000. This would be the molarity. Okay, so you can calculate the molarity from this equation. Obviously you can remove this point and have a 0 here, cancel these two thousands, then do the calculation. Let's do another question, which is, what is the molarity capital M of NH3 aqueous solution having density of 0.9 gram per ml, which contains 17% NH3 by weight. Okay, so simply we have been given in the question that 17 gram NH3 is there in 100 gram of solution. Okay, therefore volume of solution would be 1000 over 0.9. okay, and molarity would be number of moles of NH3, which is 17 over 17, which is the molar mass of ammonia. Volume is this is in ml into 1000. You can do the required stuff, so the answer would be 9m. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on molality and molarity. Okay, so till then, good luck and goodbye.